All right. We're going to be dealing with cubic functions now, right? And again, the most simple cubic function is just x cubed. That's the parent graph, right? It hasn't been transferred or translated or flipped or stretched or rotated, anything. Note that a function, f of x equals x cubed, is a one-to-one function. I'm going to highlight the original one here. And I've kind of worked a little bit ahead of you guys. We can see that right there is the original function in dark. So we don't have to restrict the domain, right? This guy passes the horizontal line test. So no domain restriction needed. All I really did is I took all the points, like this point right here was -2, -8, and I switched them, -8, -2. I plotted it. I had 2 points in the middle, actually 3 points, right? And I should have gone through it over here, which I didn't. I should have done that a little better right there. I had -1, -1, 0, 0, and 1, 1, right? And then I took this point of 2, 8 and changed it into 8, 2 over here, and I graphed it, right? I did this just by switching x and y's from the points that they gave us. But I also put it over here, right? I graphed it again over here so you could see that the inverse of this is a reflection over y equals x. I just want to kind of point out all the things that make an inverse, and I want you to be able to see it. So there it is with y equals x. We can see it's a reflection. This came down here, this came up here. Alright, now let's go ahead and do everything we did before. We're finding the inverses, we're graphing inverses, and so on. And I kind of started this guy off. Alright, I realized this. Oh, I'm stepping on stuff on my computer that I shouldn't be. This equation was f of x equals 1/2 x cubed. And I just gave myself a series of numbers that will actually work. I started in the middle, 0, right? This is kind of easy. 0 cubed is 0 times 1/2 is 0. -1 cubed is -1 still, right? Because now the sign doesn't change because we have an odd exponent up there. And 1/2 and -1 is -1/2. And here's a nice one right here. -2 cubed is -8. Half of -8 is -4. And just kind of plugging into the equation. And with 1, 2, and, well, 1 and 2 anyway, I get the same answers, but now they're positive, right? I put in 3 just because, and I want to show you how quickly these cubic roots kind of grow. Cubic equations kind of grow. 3 cubed is 27, and half of 27 is like 13.5. So we're really not going to fit any points other than these on here. Let's plot them. I got my 0, 0. I've got my 1, 1/2. I've got 2, 4, which is way up here, and then it shoots all the way off the graph. And this guy does the same thing, right? I got what, -2, -4, and then before it even gets to that -3, it shoots all the way off the graph. That's my parent graph. All right. So let's go ahead and solve this, right? I'm going to use it. Again, we're not writing an equation, right? So we can go ahead and solve this by switching x and y. So I'm going to say x equals 1/2 y cubed. Multiply both sides by 2. We get 2x equals y cubed. We want to make this just y, so we're going to take the cube root. We're going to get y is equal to, right, positive or negative cube root of 2x. Wow. All right. I'm going to plug that in. So we'll try composition of functions, but let's go ahead and come over here and plot some points and see what it looks like, right? So I'm going to rewrite this as f inverse of x equals positive or negative cube root, put that little index in there of 2x, and we can plot some numbers that are kind of easy. So I'll say x and f of x, and it's going to be harder to find some numbers that are easy here just because cube roots are tougher. So I'm going to try to find numbers and give me a cube root. Let's plug in a 0. 0 is kind of easy. If I plug in a 0, 2 times 0 is 0. Cube root of 0 is 0. So I know I'm going to have that point in common right there. I'm going to go ahead and plot in. I'm going to go with a 4 because I know the cube root of 8, and 2 times 4 is 8, right? If I plug in 4 there, 2 times 4 is 8. Cube root of 8 is 2, right? And, well, I did positive or negative up here, and I shouldn't have, right? I wasn't doing square roots, I was doing cube roots. I'm going to plug in a -4, which is going to give me a -2. And I think that's all I'm going to do. I kind of had the inverse of what I already did already. I got 0, 0. We got 4, 2 right there, and negative 4, negative 2. And I can see that my graph is going to do this. And it's sort of looking like an inverse, right? Where this came up here and this came down here. But let's test it with composition of functions. All right, so I'm going to say the f of f inverse of x. We just got done reviewing this on the other one. I'm going to take the original function. Here it is up here. I'm going to write 1/2. I'm going to write it without the x, but I'm going to give myself a lot of room, cubed, right? And then I'm going to plug this function in, which is the cube root of 2x. Just like squares and square roots, cubes and cube roots cancel out, so I got 1/2 of 2x, and 1/2 of 2x is just x. It works out. The f inverse of x is in fact x. Okay, so we can see that guy. Let's go ahead and do another. I'm going to come over here and try this guy. So I'm going to plot some points. I'm going to plot points around 9, right? So I'm only choosing it because I see that negative 9 there. Well, you know, let's just plot some points because it's a k value, not anything else. I'm going to plot points around 0. So this will give our x and our f of x, right? So I plug in a 0. 0 squared cubed is 0 minus 9 is negative 9, right? If we plug in both 1 and negative 1, 1 cubed is 1 minus 9 is negative 8. Negative 1 cubed is negative 1 minus 9 is negative 10. I'm almost off this already, but let's go ahead and plug in 2 and negative 2. See what we get. 2 cubed is 8, right? Minus 9 is negative 1. Negative 2 cubed is negative 8. And totally negative 17. Off the chart with that guy. Let's plug in a 3 and see if it appears. 27 minus 9 is 18, and that's not going on. So basically the range we can see is between here and here. Let's plot them. Alright, so I got my 0, negative 9. And let's go up to negative 2, because this scale looks like it goes by 2s. This one didn't over here, but this one goes by 2s. Maybe that'll still be on the chart. Let's check it out. Nah, it goes only up to 13. So let's go to 2, negative 1, which would be right about here. And we'll go to 3. 18 is up there. So I'm getting something that kind of looks like this. And then I've got negative 1, which is in there. Negative 10. And I should actually have started right there. Negative 1, negative 10 is going to be here. Negative 2, negative 12. Oh, 17 is way down here. So I got a graph that kind of looks like that. And we can see it. So I'm going to come here and we're going to find the inverse. So let's do the inverse of that. So I'm going to replace that with a y. Let's do it right here. Y equals x cubed minus 9. We're going to switch x and y. So we got x equals y cubed minus 9. We add 9. X plus 9 equals y cubed. We're going to take the cube root. And we get y equals the cube root. I need to have a 3 in that index of x plus 9. And we'll rewrite that as the f inverse of x equals the cube root of x plus 9. And let's see if we can plot a few points. I'm going to start with points that I've already got on my original graph, right? Because I can see negative 9 worked out all right. And also, if I put a negative 9 in the cube root, I get a 0, and I know the cube root is 0, 0. So I'm going to go negative 9, 0. Let's go to negative 8, and we'll go negative 10. Negative 8 gives me positive 1. Cube root of positive 1 is 1, because 1 times 1 times 1 is 1. Negative 10 gives me negative 1, which gives me cube root of negative 1 is also negative 1. Let's try these. Alright, so if I plot this, I've got negative 9, 0, which is right here. Alright, I've got negative 8, negative 1. I've got negative 10, negative 1. I'm going to try one more below negative 8 that would work out. I know the cubed root of, well, 27, but let's try it. What would I have to do to plug in to make this 27? 18. This could be a little bit weird. So 18 and 9 are 27. The cube root of 27 is 3. So it's going to be a point way out here, right? And I'm getting something that looks like that, right? So we can see, I think I might have messed up my scale a little bit on that last problem, but we can kind of see that this is a reflection of this. All right. One more thing, composition of functions. I believe it says, yep, we're going to confirm inverse with composition. So here we go. Probably better than graphing on these ones because they kind of have such abrupt changes. We're going to say the f inverse of x equals, so the f function is just this, right? It's x cubed minus 9. We write that without the x up here. And now we're going to plug in the cube root of x plus 9. It's kind of obvious that it's going to work. These guys cancel out, and I get x plus 9 minus 9, which gives me just x, and it is in a cube root. I want to show you one more thing, that there is a problem. Try the problem, and we will almost be done with this. So try this guy right here. And again, you're going to graph it. Just use a chart or a table. I'd start at 0. After you graph it, you're going to find the inverse, graph the inverse, and check with composition. I'll see you guys.